I'm Ramakrishna Reddy. Today we are going to discuss about given a bunch of vectors, we would like to sense whether they are linearly independent or linearly dependent. Suppose you are given a bunch of vectors, say x1, x2, and so on, xn, or v1, v2, vn. V1, v2, vn, that's the standard representation. Some combination of these vectors, say 2v1 plus 4v2 minus 6v3 and so on, or some other combination. That combination we call the linear combination of these bunch of vectors. For example, here 1, 2, 3, 4 are two vectors b and c. Certain combination of these two vectors, namely 2 times b and 3 times c, yields another vector 11 and 16, which we'll call AA. Now we can say A is a linear combination of two vectors b and c, where these 2 and 3 they are called scalars, meaning basically these two vectors, namely b and c, are stretched by 2 units and 3 units. Then we got another vector 11 and 6. That is, we got A through b and c by a certain combination. That combination we call a linear combination of b and c. By changing these two constants, 2 and 3, I call as C1 and C2, that generates whole bunch of vectors. In fact, that may generate a space itself, called a vector space, right? So we say the entire space is spanned by these two vectors, namely B and C, right? If these two vectors B and C are linearly independent, then I can say the entire space is spanned by these two vectors B and C. So they form the basis, right? Basis is nothing but a sort of coordinate system in which geometrically we view all the data or all the vectors. So any vector in that space, we can approach, or we can reach that vector through the combination of these two vectors, which are basically linearly independent. Then we say that the entire space is spanned by these two vectors, namely B and C. So I say the space is spanned by these two vectors. And in generic, we say that these two vectors, B and C, form the basis for this space, entire space. Now, the issue is how to check whether these two vectors B and C are linearly independent or linearly dependent. Right? We take a generic case. For example, here is an example in front of you. There are a bunch of vectors, three-dimensional vectors, 0, 1, 1, 1, 0, 1, 1, 1, 0. And we want to see whether this vector to this vector, 2, 4, 8, live in that space. Meaning, whether I can write this vector 2, 4, 8 as a linear combination of these three vectors, 0, 1, 1, 0, 2, 2, and so on. Right? Meaning, somehow we can find these three vectors, C1, these three constants, C1, C2, C3, so that certain combination of these three vectors yields 2, 4, 8. Then we say that 2, 4, 8 is a linear combination of these three vectors, right? For that, I need to ensure these three are linearly independent. So, a bunch of vectors, say n vectors, x1, x2, xn, and so on, xn, they are said to be linearly independent. If their linear combination is 0, the only way it becomes a 0 vector is if all the constants are 0, C1, C2, C3, and so on, Cn, how much effort you put, if you can't find at least one of them non-zero, so that their linear combination is 0, then they are said to be linearly independent. else they are said to be linearly dependent. If you can find at least one constant which is non-zero, but still the linear combination is zero, then they are said to be linearly dependent. If they are linearly dependent, then one vector can be expressed in terms of another vector. Then that vector becomes a redundant vector. You know? So they can't span the space. They can't form a basis. So to form a basis, the vector should be linearly independent. Here are here are two vectors which are red in color. They are independent, and blue in color. They are dependent. Right? Since they are dependent, one vector is expressed in terms of the other vector. Right? Now, let's see whether these three vectors, namely 1, 1, 3, 4, 0, 2, 3, 1, and 4, 0, 0, 0, 2, they are linearly independent or not. So what I do is, I take their linear combination, some linear combination, C1 times that plus C2 times that. I make the linear combination 0. Now the issue is somehow I need to find these four constants. Right? If all the four constants are 0, then they are said to be linearly independent. If at least one of them is non-zero, then they are said to be linearly dependent. No? So what I do is, I found this coefficient matrix. I inquire its determinant. Right? If it has a full rank, then we say that they are linearly independent. If it's rank deficient, they are said to be linearly dependent. Right? Here is an example, second example, where I formed a linear combination, and I can see that I can find at least one. In fact, all the three, they are non-zero. Yeah. So they are linearly dependent. Then one can be expressed in terms of the other. In the earlier case, here, these three vectors, they are linearly independent. Right? So if they can span the entire space, then they are said to be, they form a set. That set is called a basis. Okay. So what's a basis? Basis is a set of vectors, so that every vector in that space can be uniquely represented as a linear combination of these basis vectors. Okay. And in future, we'll see if you have a set of linearly independent vectors, how to convert them into a bunch of set of orthogonal vectors. The process is due to Gram-Schmidt process. Further, if they are orthogonal, then how to normalize them? Just divide by its magnitude. Then they are normalized. Then that basis is called orthonormal basis. So, end of the day, we love to visualize the data or matrix in an orthonormal basis. That is more convenient for mathematical treatment than normal basis. Thank you.